Now this is the statement for the triangular law of vector addition. The law states that if two vectors are represented in magnitude and direction by two sides of a triangle taken in the same order, then their resultant is represented by the third side of a triangle taken in opposite order. Okay, so for students who are hearing this for the first time, it is like same order, opposite order. What is it all about? I mean, this is the confusing part of it. So let us try and simplify what this law is trying to tell in our regular day-to-day statement. So what we can do is we can go ahead and take a particular building. So let us say this is, you're living in one costly high-rise apartment in the city, and let's say this is where your house is. So you are situated at the very pinnacle or at the penthouse of this particular building. And you arrive in your vehicle. You arrived in your car. Your idea is to reach home. That is, from your car to your apartment. But instead, what do you have to do? You have to park your vehicle and then you'll have to ascend. So what we will do is, we will go ahead and park your vehicle. So you will go park the vehicle in the underground basement or open parking space wherever it is, and then you will probably take a lift or stairs, whichever it is. So what we will do is we will put this on the 20th floor. So 20th floor penthouse is where we will assume that you are living. Now here you can see that the car is moving from its position to the parking. So this will be the direction. So it is going from, let's say, point A to point B. And from point B, what is happening? You are moving straight up to the 20th floor to point C. But where did you want to go? You wanted to go from point A to point C directly. So let's say if there was an escalator moving from point A from your car to the 20th floor, things would have been very easy. Just get out of the car, climb the escalator, and you are inside your house. But instead what you do? You have to change direction twice, which is nothing but the triangular law of vector addition. So if we are taking two vectors in the same order, so A, B and BC are two vectors, or if I take, let's say, the alphabets that are there, so I can simply take this to be P vector, this is Q vector. So P vector and Q vector are in the same direction, A to B and from B to C. The resultant vector that is there is in the opposite direction. In general, it has to come down towards the P vector, but rather it is going in the opposite direction. Now here you can notice that I've written it as boldface, but in general when we are writing, it is always better to put the arrow marks. So I can clearly tell that the resultant is nothing but P vector plus Q vector. Well, mathematically this is all fine. You get a very good picture of what is happening here. Now this triangular law of vector addition, you might have known or you may not have known. This is what is present in the GPS systems. Now if you have used your Google Maps when you are traveling for directions, even though there is a shortcut here, a path, let's say where you can take your two-wheeler or you can ride with your cycle, whichever is your choice of vehicle, or which you can walk by like this. It would generally tell, go straight, take a left, and your destination is in front of you. It would never suggest this path. Though sometimes it would suggest this path if there's a traffic jam here. So your GPS system basically works on the same idea or the principle of the laws of vector addition. So this was the first law, that is the triangular law. Now let us look at the second law, that is the parallelogram law. The parallelogram law of vector addition states that if two vectors are represented in magnitude and directions by two adjacent sides of a parallelogram drawn from a point, then their resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. That means if from the origin, so I've got two vectors here, P and Q, and from the origin, if I align P and Q such that the tails of both P and Q are meeting at point O, then the diagonal of this parallelogram that is constructed is what is the resultant, which is the parallelogram law of vector addition. Now, what is this and why is it so different from the triangular law? Well, it is not different. Now, what has happened is, how do you get a parallelogram? A parallelogram is nothing but a rectangle that has been bent. In the sense, if I draw a rectangle, and this is how I'm going to draw my rectangle, you can see that the length on two sides are equal, the breadth on two sides are equal. But let's say I apply a small force here, and if I can align this, so what I'll do is I'll just shift it like this. So I've just moved it forward, keeping the base a constant. So here, this becomes a parallelogram. And as you can see here from this diagram, this parallelogram has got two triangles. OBC is one triangle, and the other triangle is triangle OAC, where OC, which is the diagonal, is the bisector of the angle between P and Q. Now, how does it bisect? I'm not saying it's equally bisectional. It just divides the angle between vector P and vector Q here. So here you can see I've used geometry and I have labeled the sides of the rectangle. But if I have to look at my final answer, that the resultant that I'm going to write is simply going to be P vector plus Q vector. So this is how we do it geometrically. Now, in both the triangular and parallelogram law, we can see that it's made out of triangles. So I can actually apply the triangular law here. So what I will do is, this and this are same. So I can simply call this as Q vector, and this I can call it as P vector. So instead of taking OB, I can consider AC because it is the same magnitude. And if I put the arrowhead here, it is the same direction. So here also you can see OA and AC, that is P vector and Q vector, are in the same order. The resultant is in the opposite order. Now this makes things interesting. So anytime you have to use a parallelogram law for vector addition, you can use it easily with the understanding of the triangular law of vector addition. So when we are doing this vector addition, geometrically I have shown you, we have used formulas, that's okay. But how do we actually do it? Now, in order to do it actually, we are just going to use the magnitudes of these vectors and do it. It is not going to be with anything else. We're going to use the magnitudes as well as the angle that is formed, which is always measured from the x-axis upwards. So for this, what we will do is, we will have to draw, let's say we'll take the triangular law, we'll take two vectors, and from there we will go ahead and calculate the magnitude and the final direction in which this particular resultant has to be. So here you can see I've got resultant vector is equal to P vector plus Q vector. That's it. I have not spoken about what should be the direction of the resultant. If we use, let's say, the idea of north, south, east, west, I can tell that this is in the northeast direction. But exactly at what angle it is, I'll not be able to tell. And that we can do using a combination of both algebra and trigonometric functions.